Instagram. Homework help. You get homework help. Let's begin, shall we? You should be on page 60 and 61. Let's get to work together. I clear my throat a lot when I'm making these videos. Sorry. Or maybe I'm getting sick. Oh no. Alright, Janae has 36 pennies. I didn't mean to cross it out. I meant to underline it. 36 pennies. Nate has 23 pennies. Who has a composite number of pennies? Now, composite means that when you find factors, you can find more than just one and itself, whatever the number is. So think about 36 and 23. One of them has lots of factors. One of them, the only factors it has, is 1 and itself. That's called a prime number. So, who has a composite number of pennies? Janae or Nate? Dun, 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 dun. Bah, bah, bah. Well, since 36 pennies can be divided into 3 equal stacks, bling, blang, bloom, of 12. In other words, you know what they're saying there? The 3 equal stacks of 12, that's the same thing as 3 times 12 equals 36. But 23 pennies can't be divided into more than 1 equal stack. Look, you've got 12 right here and then 11 right there. And it doesn't matter how many different ways you try to make the stacks. If you use all of the pennies, all 23, it won't be divided into more than 1 equal stack. It'll always have leftover stuff. 1 times 23 is the only way to get to 23. 2 times nothing works. 3 times nothing works. Nate has a prime amount. But Janae, she's our winner. She's the one with the composite number. You can also use area models to help understand the problem. With composite numbers, you can make area models that are more than just 1 row wide. For example, see how all of these in a row, if you added them all up, they would equal Janae's number of 36, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and then going down it's 1, 2, 3, 4. 9 times 4 equals 36. With a Nate, you can't do that, because if you try to do it with Nate, all that you would get is like a square, but you'd have like these missing pieces, or a rectangle, but you'd have like a missing piece. It would feel like something's missing. The only way you can make it not look like something's missing is if you do it in 1 row. And if you can only do it in 1 row, it's a prime number. It's not composite. Now you will explore the problem from the previous page further. So the exact same stuff we're talking about. What factor pair is shown by Janae's stack of pennies? So look back at that real quick. It's on page 60. We're on page 60 and 61, by the way. What factor pair do you see? Well, you see 3 rows, 3 columns, and how many are in each? How many little pennies are there? 12. So the factor pair that we see in the stack of pennies is 3 and 12. Is 36 a prime or composite number? You want to say that it is composite. Go ahead, spell it out, spell the whole thing out. I'm not going to. It's right there. Not hard to spell. How do you know? All right, this thing I will type out for you. How do you know? I know because it has more than just 1 factor pair. Because if it only has 1 factor pair, 1 times itself, then it's not composite. Is 23 a prime or composite number? 23 is the other one. 23 is prime. How do you know? All right, I'll explain that real quick. I know because the only factor pair it has is 1 and 23. I'll put in parentheses itself. Explain how you can use models to decide if a number is prime or composite. Well, let's use a little number for example real quick, like 4. 4 is composite because you can arrange it in more than one even looking way. 1, 2, 3, 4. But you can also go 2 times 2 and put 2 on the top and 2 on the bottom. So that's how you know 4 is composite. But a number like 5, well, you can do 5 in a row. That's one thing you can do. 1, 2, 3, 4. But can you do it any other way? Think about it. Oh, yeah, you can keep going. No, you can't. Yes, you can. No, you can't. Watch, watch, watch. What are you going to do? Put 3 on top? Remember, we're dealing with 5 here. So how much goes on the bottom? You can't put another 3. That'd be 6. So you can only put 2 on the bottom. And that looks, it's not complete. It's not complete. What else you want to do? Huh? What else you want to do? Want to put 4 on top and 1 on the bottom? Want to put 2 on top and 3 on the bottom? All right, we'll do that. 2 on top, 3 on the bottom. It's not going to be complete. It's still going to look like something's missing. Like right there. Something's missing right there. So that is what we're talking about here. You can use models to decide if a number is prime or composite. You can use models by checking to see if you can only make even rows. And I'm not just talking about straight across one time, because you can do that with any number, just straight across. I'm talking about more than one row. Can you make more than one row that are all even, and when you add them up, 1, 2, 3, 4, 5, it still equals a number? 5 can't do that because it has a row that's not the same as the other, but 4 can. See, those rows are the same. Use what you just learned to solve these problems. Okay. Miss Ronaldo is picking up 17 playground balls after recess, and she wants to put the same number of balls into each bin. What are the different ways she could group the balls? 17 playground balls, and she wants to put the same number in each row. Think about 17. Well, we can do 1 times 17, and that would be, that's one way. We could do, think about it. Draw rows if you want to. There's no other way. 2 times, nope. 3 times, nope. There's no other picture you can draw. Well, what if I put a 5 on top and 5 after that? Okay, do that. Then you'll have 10, but you still have to make it to 17. So how are you going to make it to 17? 5, 10, okay, 15. It's still even, Mr. Graham. It's still even. Each row has 5, but now you're at 15. You have to make it to 17. So I need 2 more. Oh, only 2 more. Dang it. Dang it, this row is incomplete. No matter what you try to draw, the only way to do it is one line with 17 in a row, just like 1 times 17. That's the only way to do it. And when that's the only way to do it, guess what kind of number it is? It's not composite. It's prime. Alright guys, thanks for sticking with me. This gets easier the more you do it, and even easier once you become a master of multiplication. I'll see you guys next time. Have a great day. Bye.